Hi, my name is Anastasiia, and today we have really interesting topic to talk about. Well, this is what I usually say when I'm doing cryptographic talks, and today is cryptography talk. So today we actually will try to ride the hype train, and we try to talk about end-to-end encryption and how it's not the same as security and how it's not the same as privacy. You know, all these scandals with WhatsApp, with secure messengers. This is like the inspiration for me to do this talk because people ask me often, like, hey, this is like secure messenger, or if this is secure messenger. So my name is Anastasiia, and I'm working as a head of customer solutions and security software engineer at Cossack Labs. Cossack Labs is a data security company. We are vendors of security tools, and we basically create tools for data security for cryptography, right? So we do all this kind of encryptions like from multiple platforms. I also maintain an open source cryptographic library called Themis, and I'm involved into creating, end-to-end encryption schemes for different projects because like we work with different companies and either they take our software or we build some custom encryption schemes for them. For example, we worked with Bear application, and this is the application, like a note-taking app, and we implemented together with Bear team, we implemented end-to-end encryption for note taking, right? Also like things like applications like AppSpectre, which is remote debugging tool for iOS, Android, and like desktop. They also have end-to-end encryption flow. Sometimes we audit end-to-end encryption things like user base, for example. This is like a web application with end-to-end encryption that allows you to store data in a database and to encrypt it all the time. So I know a lot about building end-to-end encryption applications, about auditing them, and about typical mistakes we developers make when try to do encryption. So I also see a lot of misunderstanding from people about security, about privacy, about encryption. For example, we got this comment on Twitter regarding Bear, regarding the thing that Bear uses into encryption. So the comment was like that end-to-end encryption for user content implies that all the content is encrypted, which unfortunately it does not, right? Just end-to-end encryption itself doesn't mean a lot of things. It doesn't like so end-to-end encryption doesn't mean that all your data is encrypted end-to-end and this encryption is good, modern, and it is enabled by default, and not only data is end-to-end encrypted, but local data is encrypted and backups are encrypted. So just end-to-end encryption doesn't mean all the things. And when you open like landing page of some application and they claim to have end-to-end encryption, they might be totally honest with you, right? So it's not like a malicious, they might be totally honest with you, but they mean that they use end-to-end encryption for certain things. For example, they can encrypt only your like messaging data without encrypting metadata, without encrypting attachments, pictures, etc. Well, let's avoid the case that some people called TLS end-to-end encryption because it's like from end to end, right? No, it's not. We will talk about TLS a little bit later. Um, yes, some people implement end-to-end encryption, but using really not appropriate, let's put it this way, not appropriate ciphers for these issues. And don't even get me started about XOR and about using XOR for encryption, okay? Because I just recently had a conversation with developers who tried to use XOR to encrypt the data. Right, so opt in and opt out. You know, in some messengers, in some applications, end-to-end encryption is enabled by default. But for many of them, end-to-end encryption is not enabled by default, and you should go somewhere in the settings and you should like enable it explicitly for some piece of data flow you want, right? Because end-to-end encryption probably will make performance of your application worse. It might not. That depends on the design of the scheme, but it might affect performance. It might affect like using the same application from multiple devices. Next, Remember all these stories about WhatsApp, about Signal, that they use end-to-end encryption, but they store their backup data in a clear text? Yeah, because using end-to-end encryption doesn't mean that the data is magically gets encrypted at rest on the site. No, again, depends, but in many schemes, you need to implement this additional like data at rest encryption when you store history, when you store archive, and when you store backups, obviously. And of course, end-to-end encryption doesn't mean that application doesn't collect all your other data like phone numbers, locations, IPs, yada yada. So, for example, to ride this hype wave, Signal, WhatsApp, Facebook Messenger, and Telegram, all these applications, they use end-to-end encryption. But you know from your experience, they are totally different and they behave in a different way. And this screenshot from Apple privacy with Apple privacy forms, it shows how much data they collect. Yes, they use end-to-end encryption, but yes, they still collect a lot of data. Well, Signal, for example, doesn't collect a lot of data, but Facebook Messenger, they collect a lot of data. And that's fine because end-to-end encryption doesn't mean privacy. But just let me take this moment to explain more about messengers. So if you're really curious how to compare the messengers, if they all use end-to-end encryption, but they're very different, take a look on this site like securemessagingapps.com or these Google spreadsheets. There is like a lot of messengers and they're very different. For example, the first row here, does my app secure my messages and attachments? Remember we talked about that like a couple of slides ago, right? Attachments, do the encrypt attachments. And as you can see, Signal, Threema, and Wire, they do. For others, sorry, attachments might not be encrypted or might not be a part of end-to-end encryption flow. Then it also depends on company jurisdictions, what things they are obliged by law to do, right? That's why it's not only important to look on technical part of implementation, but also on regulations, on laws. Does this company have had any known issues with providing information to government, to NSA, etc., etc.? So take a look on this table to realize how different all these end-to-end encryption applications are. And we will continue with privacy, security, and end-to-end encryption. So, because these are three different things. Privacy means, like for developers and for users, what data this application collects, how this data is being linked to the user, who has access to this data. As a company that collect this data, do I give access for the government to read this data? Where my servers are located, right? Also these user privacy, data privacy regulations like GDPR, CCPA, and local laws in every country, they are about privacy. And obviously privacy depends on trust. If you trust this company, if you trust this government, if you trust the system, right? Security is different. Security is how we protect sensitive assets like data, like access, our application code, our databases, servers, backups, yada, yada, yada. When we work on security, we have these, different directions: application security, data security, infrastructure security, yada, yada, yada. And we use guidelines like OWASP, ASVS, which is application security verification standards, MSVS, which is the same but for mobile, some software assurance maturity model, etc., etc. This is security. It doesn't mean privacy. And the last bit is end-to-end encryption. This is like more a technical term. It means that some data is encrypted for some user on some end, like usually inside the application. And then this data travels encrypted across all the servers, across all the data centers, until it gets back to the same user or to another user, if it's a chat. And only then it gets decrypted. And this ends, like the same user using like different devices or different users, these are the ends in terms of end-to-end encrypted. And this means the data is encrypted from this to this, okay? And Any combination of these things are possible. Your application can be super nice. They can use like really modern cryptography, anti-encryption, yada yada, but still sell your data to other companies. Okay, or your application can be real good from privacy perspective. It can be really good from security perspective, but doesn't have anti-encryption, and that's fine. Okay, after we understood these, let's move forward. Let's talk about encryption schemes and how data flow affects encryption. Because we're talking encryption, 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 encryption. Let's imagine this very simple web application. Okay, it's not like super simple, but it's still very simple. This is an online shop with a web application, mobile application, some admin service, and of course we have order processing, we have some payments, we have databases, we have analytics. Obviously, the real schemes, the real applications are much more complicated. You can imagine all the layers of caching, of firewalls, of many different databases, queues, etc., etc. But let's stick with this one. So encryption can happen almost anywhere here. And this will be different kinds, ways of encrypting data. For example, a web admin page, web application, and mobile web application, they are source of data. They work as data input. So we can encrypt data there. Logs and analytics. We can encrypt logs. Usually we encrypt logs when we generate logs, but we also can archive logs one by one and encrypt logs as files, right? Processing. We might want not to do processing on clear text data. We might want to do processing on encrypted data. And of course, storage. Obviously, in most cases, we need to encrypt data at storage, at rest, right? So depending on when, how, and who encrypts the data, the encryption things are different. When we say data at rest encryption, we mean that data stores locally and it's encrypted. Think about file system or operating level encryption. Think about database encryption like TDE. When we talk about data in transit encryption, we mean that there is some connection between nodes, between components, between servers, and the data is encrypted in between on this connection level. And TLS is a good example of that. It's transport layer encryption, okay? But also TLS is not the only one. IPsec, SSH, they also encrypted protocols. They just work on different level of OCI model, but still, they also example of transport layer encryption. Next, if application itself encrypts the data, this is application level encryption. If this application appears to be a client side in our scheme, this is client side encryption. If this application appears to be a server side, this is server side encryption. If this is a proxy, you understood the idea, it can be proxy side encryption, right? So this name means where the data is encrypted. Next one, the difference. This is a tricky part. The difference between TLS, transport layer encryption, and application level encryption. Take a look on this scheme. Imagine we want to send an encrypted message from Alice to Bob, right? And Alice and Bob are different servers and different components. So when we're using TLS, the data is encrypted only in between, from Alice to application 2, from application 2 to Bob, only in between, only in transit. And this encryption decryption is made by operating system layer, on like operating system layer. If you have application, if Alice is an app, the data gets decrypted to this app by operating system that will unwrap TLS package. Check all the certificates, make sure the connection is fine, make sure that certificate is not expired, it's active, the certificate authority is legitimate, trusted, yada yada, and then decrypts the data and then gives decrypted data to the application, right? So TLS bounds on the boundaries of the application. Application level encryption means that application code is responsible for encryption and decryption. So for the same example, let's imagine that Alice is encrypting data and it's written in the code. The data is being encrypted in the code. And then it gets encrypted all the way to the Bob, which is also an application, and it also has some decryption code, and data is being decrypted in the code. So data gets encrypted all the time. Obviously, in between, there can be TLS. So for those connection things, the data gets encrypted at least twice with our own application level encryption and TLS, right? But the main idea here is the data is being encrypted and decrypted by application code, usually like by your custom code. Okay, now, usually we don't want to encrypt all the data. I mean, yeah, this sounds really attractive, but no. Usually we want to encrypt some data fields. Imagine you have huge JSON model, right? And you don't want to encrypt all the things. You want to encrypt all the sensitive fields, like I know, email or like SSN or like how much money does this user have, these kind of things. And if you encrypt only certain fields, you can name your encryption field level encryption. So you can divide, instead of encrypting the whole model as a blob, you only encrypt certain fields. Next, end-to-end encryption finally. Remember our previous example with Alice and Bob. Actually, it was an example of application level encryption, which in that case was also end-to-end encryption. The idea is that application encrypts and decrypts the data, and server side doesn't have access to data in clear text or to keys that can decrypt the data. If you encrypt data on your applications, but you store your encryption keys on the server side, that's not end-to-end. I mean, sorry, you have a way to decrypt the data. Right? So usually in end-to-end encryption schemes, server works just as a medium for key exchange, but like public key exchange. It doesn't have keys that will allow it to decrypt the data. Now, more complicated things. Transparent encryption. Transparent means transparent for, someone, right? For example, transparent database encryption, TDE, means the database is responsible for encrypting and decrypting the data, but applications, all those like applications that connect to the database, have no idea that the data was encrypted, right? So database encryption is transparent for the applications, which means that usually database or database driver or like some daemon or some sidecar here is responsible for key generation, key store, and like key management procedures, and basically encrypting and decrypting, which might sound tricky because you understand that your encrypted data and keys to this data are kind of put together in one basket. The next term is transparent proxy-side encryption. Now, again, transparent for whom? For applications. Now, imagine that in front of your database, you have a proxy application, who is responsible for data encryption and decryption. So this application manages keys, goes to keys somewhere, encrypts the data, stores this data to the database, reads the data from a database, decrypts the data, yada yada. Application has no idea that data was encrypted or decrypted there. Database has no idea that it stores encrypted data because it doesn't just have any ways to determine that the data is encrypted. It's just some binary data. And we have someone, proxy, who is responsible for encryption and decryption. Transparent for other parties of the system. Now, obviously, there is a lot of, again, questions with TLS and application level encryption. And again, some comment from Twitter about an article I will share you soon, that TLS is quick and easy win, while well-designed application level encryption is way beyond developers' reach. And that's unfair to compare these two in this way, obviously, because these are two different things. They have different threat models. Take a look on this. This is a table from the article we wrote which is called application level encryption for software architects, and it's placed on InfoQ and been written by Eugene Pilankevich. So this is a table from this article. Imagine different kind of encryptions, like different ways of encrypting data, like TLS, data in transit encryption, data at rest encryption on disk or file system level, then database encryption or TDE, then application level encryption, and the last bit is end-to-end encryption. So these different ways of encrypting data, they have different security guarantees and different events and they protect from different events. Okay, with for example, when we're talking about TLS, it doesn't protect from someone physically accesses the server and grabs the server from a data center or your home office, because TLS is data in transit encryption. However, disk encryption, database encryption, application level encryption, end-to-end can protect from that. TLS, the main purpose of TLS was to protect from man in the middle, from somebody reading the communication. Yeah, and TLS does that, but it doesn't protect from privileged database access. Privileged means that you have admin rights. Basically, you can decrypt the data in a database because you have admin rights and you can read the keys, right? Privileged is system access, when you have root access to the server. And if you have root access to the server, you can disable this encryption. So backups, logs, snapshots. The data can be encrypted in your database, but database backup is not encrypted, which is obvious scenario for many incidents that happens all the time. If you look on these different ways of encrypting data, we see that application level encryption is kind of good, but end-to-end encryption, that's the best. Because if data is encrypted end-to-end, encrypted in your application, so you don't care if someone will grab your server, data is encrypted. If someone tries to read the connection line, even if you don't use TLS, data was encrypted on the application. It's already been encrypted while it's in transit. You don't care if someone has admin rights to the database, because data is stored encrypted in the database because it was encrypted before on the application, and database has literally no means to decrypt this data, right? So if you have admin rights, if you have admin rights for the system, again, data was encrypted somewhere on the application level. And even if you're lucky and the data gets encrypted all the time, it will be encrypted in backups and snapshots if you don't decrypt it before. And when we say that end-to-end encryption, it's so cool. Yeah, it's so wonderful. All this green arrow, like checkboxes all the time. Why we don't use it everywhere? And here is a tricky thing. It's expensive. It's very expensive. It's super expensive because it's not only encryption you need to take care, which is a problem itself, right? But with end-to-end encryption, you need to care about key management, especially about key management, like key layout, where to store keys, how to rotate keys, how to do key revocation. Do you need to re-encrypt the data encrypted with the key if the key was leaked? Probably you do. How you will do this key data re-encryption and key rotation? How to back up keys? Because imagine you have this data encrypted and then you back up the data, then you rotate the keys. Who will be able to decrypt the data? Right? You need to have some backup keys procedure or re-encrypting data during backups. Then, of course, all these problems like how to search encrypted data. Totally possible, but performance penalties, like tiny performance penalties. All these problems with like logging and monitoring. When you log encrypted data, cool, right? You understand everything. And obviously we have wonderful NIST guidelines applicable for this case, 853, which is about security controls, and 857, which is all about key management. So end-to-end encryption, that's cool, but it's really expensive. I made this like pain curve myself, so you just opinionated piece. TLS, it's really easy to make. Okay. And remember, yeah, end-to-end encryption is really great, super expensive, but again, as we said previously, it doesn't mean if your application uses end-to-end encryption, it doesn't mean that all your data is encrypted end-to-end and this encryption is good and it's enabled by default and also your local data is encrypted and your backups are encrypted. Sorry. Okay, now let's talk about more complicated schemes because this was like kindergarten level schemes. Let's move forward. Client-side field level encryption. You already know what it means. It means that data was encrypted in the application, which in this architecture scheme is a client side. Field level means that only certain fields of data were encrypted. So in this example, we see a MongoDB client-side encryption. And you can read, so the MongoDB has this ability and you can read the MongoDB guide there. Basically, it means that in your application code, you integrate MongoDB SDK, which is responsible for data encryption and decryption, and also to get to the key vault, to generate a key, to use this key. So it's responsible for part of key management. This SDK will encrypt the data, and application will send this data encrypted to the MongoDB. So MongoDB doesn't have, as a database, doesn't have any ways to determine that data was encrypted. It just receives some binary blob from the application. That's fine. It just stores as is. When application wants to read the data, it reads encrypted data, and Mongo SDK is responsible to get to the keys and decrypt the data. Right. What's the potential problem here? Also, it depends on your threat model, okay? But for some applications, these schemes might not be suitable because we have super powerful application, which is encrypting and decrypting data. And this is a risky thing. If it's like a web application, for example, if this application has a lot of risk and threats, because we have, basically it can be like public facing application available to the internet, and it has Mongo SDK, which goes to the keys. You got everything really under attack, in the potential attack. If this is the case, another scheme we previously talked about might be in place. Proxy-side transparent field level encryption. Again, proxy-side means that data encryption happens on proxy. Some applications it works like proxy. Transparent means the data is encrypted transparently for parties in the system. They have no idea the data is encrypted. Field level means that we don't encrypt everything. We encrypt only certain fields we would like to get encrypted. So in this example, instead of application doing encryption, we have a tool, Acra proxy, and this is a scheme from our open source software called Acra database security suite. Basically, the application connects to the Acra, and Acra is responsible for data encryption, decryption, for receiving keys, for performing all the key management, key rotation, key encryption, like data re-encryption techniques, yada yada. So when application sends the data, and obviously they use TLS, right? Acra, depending on the configuration, will take these fields, encrypt them, and send data next to the database. So database have no idea that the data is encrypted. It's just encrypted. And database doesn't have any keys. And database doesn't have any means to decrypt the data. When application wants to read the data, it reads the data through Acra to the database. Database returns encrypted data. Acra understood that the data is encrypted. It gets the keys and decrypts the data and gets data back to the application. Application has no idea that the data was decrypted before. These schemes work very nice when your application is publicly facing because it doesn't have any encryption code, or when you have dozens or hundreds of applications and you need to have a centralized data encryption control that you can monitor only one thing that you can monitor, then you can have all the defenses, and it's part of your inside infrastructure to manage encryption, to manage keys like in a centralized way. And all your databases will have no idea that the data is encrypted in them. That's basically it. Thank you for your attention. And this is a list of really nice articles. One of them, application level encryption, I mentioned before. Another two are really great. So the write-up in 2017, wow, 4 years ago, about hunting vulnerabilities in Signal by Jean-Philippe and Marver. Take a look. Signal, obviously, all applications have bugs, so Signal had a lot of bugs. And the third one is a write-up, is a newsletter from Filippo about a bug in Telegram protocol, which is also already fixed. But this is a very suspicious bug, and if you understand how XOR works, right? So it's like bidirectional function. I suggested to read this small newsletter because it's really, really nice write-up about things that might look like security improvement, but in effect can be backdoor. But we don't know. I mean, we don't speculate about that, right? We don't know. So that was me. My name is Anastasiia, and ping me in Twitter or like join my other talks. Bye bye.